Energy Metabolism, Part 1. What is the main source of energy for the body? Do you remember Dieter? Well, his physician told him that he should exercise more, so that's why Dieter's going for a run today. The source of energy his muscles initially use is ATP. ATP, or adenosine triphosphate, is a molecule containing high-energy phosphate-oxygen bonds. When a phosphate group cleaves off from the ATP molecule, ADP, or adenosine diphosphate, is formed. Losing a second phosphate group yields AMP, or adenosine monophosphate. Each cleavage of a phosphate-oxygen bond releases the energy stored within. Only water is required to enable the use of energy from ATP in the cells of the body. Therefore, ATP is considered the universal energy currency of the body. Since ATP easily releases phosphate, it's unstable and not available in large quantities. The energy supply from ATP is only sufficient to fuel a few seconds of activity, so although ATP is a good energy carrier, it doesn't represent an energy store. After a few seconds of jogging, Dieter's muscles switch over to another energy source, creatine phosphate. Like ATP, creatine phosphate has a high-energy bond. By the way, it cleaves off its phosphoryl group more easily than ATP. So it's not surprising that the supply of ATP in Dieter's muscles is only enough to last for around 1 minute. Afterward, Dieter's metabolism needs to gain energy from his body's energy stores. You will learn how this works in detail in the various episodes of this Chalk Talk course on energy metabolism. First, Dieter's muscles turn to sugar as a source of energy. Free sugar, especially glucose, is usually available to the body in such large quantities that they last for around an hour of physical activity. You can find out how glucose is broken down in episodes 2 and 3 on glycolysis. Gradually, Dieter's muscles begin to use fat reserves as an energy source. The breakdown of fatty acids takes longer. However, the stored fat in the body usually lasts for several days of physical activity. If you'd like to find out more about the breakdown of fatty acids, stay tuned for episodes 4 and 5 on beta oxidation. Through the metabolism of glucose and fatty acids in Dieter's body, acetyl coenzyme A, in short acetyl-CoA, is formed. Degradation of this 2-carbon unit yields carbon dioxide in the citric acid cycle. Dieter exhales the carbon dioxide during his jog. If you'd like to know more about how the citric acid cycle functions, then keep a lookout for Episode 6 of our Chalk Talk course. In all these metabolic processes, Dieter's cells not only generate energy in the form of ATP, but also reducing equivalents, namely NADH and H+, and FADH2. These reduced coenzymes temporarily store 2 protons and 2 electrons, which can be utilized again in different reactions. How these alleged reducing equivalents also yield ATP for energy is explained in Episode 7 on the electron transport chain. After jogging for a while, Dieter's tired, so he hurries home. Dieter even sprints for the last few meters. Since he's not very fit, the blood supply in Dieter's muscles isn't sufficient to deliver all cells with oxygen at this speed. Also, there isn't a large number of mitochondria in Dieter's muscle cells. To be able to sprint, his muscles need to utilize energy without oxygen. Differences between anaerobic and aerobic metabolism will be discussed in Episode 8 of our Chalk Talk course on energy metabolism. Now, the anaerobic reactions occurring in Dieter's cells produce lactate. As excess lactate can lead to acidosis, Dieter's body transforms it. How this occurs will be explained in Episodes 9 to 11, which focus on the Cori cycle and gluconeogenesis. So what if Dieter had started his morning on an empty stomach and depleted the glucose stores during his run? Well, his body could turn to gluconeogenesis to produce glucose. Some of the body's cells, such as those in the brain, can't switch to fatty acid metabolism as an energy source. Aside from glucose, the brain can also use ketone bodies as an energy source. Their metabolism will be discussed in Episode 12 of our Chalk Talk course. Back home, Dieter is hungry after his exhaustive training. He remembers once reading that pasta is a great source of energy for runners, so he eats a large serving of spaghetti. Because Dieter's very hungry, he consumes more calories than his body needs. With these additional calories, his body forms new stores of fat. After all, you never know if Dita might come up with the crazy idea of going for a run again tomorrow. In episode 13 on fatty acid synthesis, we'll show you how Dita's body creates these new reserves. Now, while Dita's taking a well-deserved rest, he wishes you good luck and hopes you enjoy our biochemistry course.